All right, hi everybody. Mrs. Ortman, JZ. Hopefully we're all hanging in there. Looking at day 9. So we're going to do the dot product of vectors here. So we are going to use, this is super important, component form of our dot product. Okay. In order to use the dot product, you have to be in component form. So think about initial and terminal points and making sure you get it into component form. Get out of here. Okay. And then we are going to use that to find an angle between them. Okay, so if we have two vectors pointing in different directions, which angle we're coming at. All right, so first things first, dot product. So here is the notation. So vector u, so this would be vector number 1, vector v, vector number 2. These are their component forms. Okay, so horizontal piece, vertical piece, horizontal piece, vertical piece of the two corresponding vectors. So you're going to take u1 times v1. So literally we take our horizontal pieces, multiply them together. We take our vertical pieces, multiply those two buddies together, and then we're going to add those two numbers up. Okay, so you're going to end up with a final number. That's where we talk about it being scalar. It's a final number. It is not a vector. Okay, so when you think of scale, like architecture and growing and shrinking and scale factors, that's where that kind of comes into play. Okay, so we're going to go through example number 1. So I'm going to pull my screen shade down. And here we are, 3, -6, and 2, 1. Okay, so we like to look at this as this is a U1, U2, left-handed problems, V1 and V2. All of my 1's multiply together, add that to my 2's multiplied together, 6 minus 6. This dot product is equal to 0. Okay? All right, so let's see here. You guys are going to do number 2. Okay, so let's check your answer. 0 times 20, 5 and -3, 20 and -15, so the dot product is then equal to 5. Okay, all right, let's move to the next piece here. Okay, so now what we're going to do is we're going to use the dot product. So this is why we need it. We're going to use the dot product to find the angle between the two, between them, when we say them, between the two vectors. Okay, so like vector 1, vector 2, if we're looking to figure out what this angle measurement is, whether we call it theta or beta or whatever, we use this formula. Okay, and what this is saying is you're going to take, in the numerator, you're going to take the dot product of the two vectors. So that's what we just did in those two previous problems. Then we're going to take the magnitude of both vectors. So you have to find the magnitude of u. So we need the magnitude of my first vector, and then the magnitude of my second vector, just written a little bit bigger. Okay, and what we do is we multiply those guys together. So you'll end up with like cosine theta equals a number over a number. Okay, then we're going to use, because we want the angle, so we have to use that inverse button that we used earlier with this information. You'll do the cosine theta of that number. Oops, sorry guys. And then that'll actually get you your angle measurement. Okay. All right, so we're going to give it a try here. Okay, so we just actually did this buddy, right? So these are the two same problems from before. So we know from the previous problem that the dot product, is equal to 0. Okay, so we're set there. So as we set this up, we're going to go the cosine of theta equals 0 over, right, dot product of 0 from previous problem. okay? And then we have to find the magnitude, okay? So if this is my vector u and this is vector v, okay? The magnitude of vector u, we're going to work that buddy out. Okay, so I'm finding the magnitude of my u. Oops, forgot my line. So the magnitude of u is equal to the square root of u squared plus v squared. So we're going to end up at the square root of 9 and 36. So we have the square root of 45. Okay, so, and we can simplify this. Oh, sorry, buddies. You don't have to, because we're going to put this all in our calculator anyways, so let's just save that step. So this guy is the square root of 45. Okay, now I have to do the magnitude of v, and we're going to get the square root of 2 squared plus 1 squared equals the square root of 4 plus 1. So we're sitting at the square root of 5. Okay, so this guy right here is the square root of 5. So we're all good, right? Okay, so if we simplify this, we know 0 divided by anything is 0. So I'm sitting at the cosine of theta equals 0. Okay, this divided by this gets me 0. We're going to cosine inverse of 0. Use my fancy calculator, and I'm going to get 90 degrees. Okay, really quickly, here's my old school calculator, remember it? Yep. Second cosine of 0, 90 degrees, and there you are. So we are looking for the area between these two vectors is 90 degrees. Okay, all right, I'm going to give you guys a problem and let you try it. So press pause so that when I come back, you'll have the answer. And these are the same two vectors from before, so you can kind of do that we did here, that little shortcut, because you already know what the dot product is. All right, give it a shot, kiddos. Okay, so let's come back here. Dot product was 5 from before, so I'm going to set my formula up. The cosine of theta equals 5 over the two magnitudes. Here's my work over here. Okay, this guy right here simplified to 0.049. Second cosine, I'm sitting at 87 degrees. Okay, all right, well, I am going to press pause, and the next little piece we have is just vocab, so I'm just going to probably screenshot it and make another quick little video for you guys. Okay, so we're actually just going to add these 3 vocab pieces on to the last little bit of this video, okay? So orthogonal vectors, I'll try to use a highlighter that doesn't make it too dark, okay? Orthogonal vectors are vectors that intersect at a 90 degree. Okay, that just means when it's all said and done, when you end up with cosine theta, you're getting 90 degrees. Okay, so that the angle between them is 0. What? Okay, parallel vectors are parallel, same slope, okay? So if you have like a vector in component form that's 3, 5, and another vector in component form that's 9, 15, okay? When you turn them into slope, rise over run, this guy would be 5/3. Rise over run, this guy would be 15/9, which 9 reduces to 5/3, okay? So that they're parallel. And then if neither of those things happen, then we just classify them as neither, which I know sounds pretty self-explanatory, okay? Coming back here, this is a tricky one. They intersect at a 90 degrees, so when you end up with your formula prior to using your calculator, you're going to get cosine theta equals 0. So that when you second inverse, that's where our 90 degrees comes into effect. Okay, so shortcut here, if your dot product is 0, the two angles are always going to be orthogonal, or we like to say perpendicular. Okay, so underneath my giant fancy screen shade are 4 problems. So we're going to put them up, and then what I'll do is I will do the problems and then upload the answers to the work for the day. So why don't you give these 4 problems a quick chance, and again, reach out if there's any questions. We hope everybody is surviving. Hopefully you can do these next 4 problems with a friend. Your friend can be from any of the classes, and you can use FaceTime, Google Chat, Google Messenger, I don't know, whatever's out there. and try to chit-chat through some of these problems to figure out if they're orthogonal, parallel, or neither, and also find the angle between them. So good luck, friends. Reach out if there's any questions. Hope everybody's well. Bye.